Alright, I can't teach you every little absolute thing that you need to do to measure a hook, but I can give you some basics. Protractor can be handy, although not for this hook. We'll cover that later. Definitely want a pencil just to take some notes. You want a good dial caliper. Well, even a cheap dial caliper, as long as you can read it well. Or you can use a vernier caliper, but it takes a little more skill to use. Obviously the hook, and something to write on. Now, I usually start out modeling a hook like this. I just draw a rectangle. Alright, that is the length and width of the hook. And you don't have to draw it the length and width of the hook. You're going to measure those things and label it. And then I draw a box here, which represents the area from here to here, or the distance from there to there. I may or may not worry about the exact arc here depending on what I'm drawing, but we're not going to cover that today. That's just the basics. And then I need to know how thick the wire is, so I may pencil in something like this just to represent that. And then I need to know details about the eye of the hook, and so I may go like this and draw another box that represents the dimensions of the hook eye. Alright, the round portion and how far it goes before it's straight. And I don't actually have to draw that, I just need this information, okay? And I may take a couple of other dimensions as well. If you notice, this eye isn't perfectly centered on the shank of the hook, so I need to know, probably need to know whichever side is further off center, okay? But we'll get to that in a minute. Basic measurements. The first thing I want to know is the wire thickness. Okay, now you can measure it here. You can measure, and if you measure it there, you want to measure it both ways. In this particular hook, it's pretty close either way, about 81 thousandths. But you need to know how thick this is, because the eye never comes together perfectly. Okay, and that's almost 85 thousandths. So I would probably put down, just for working purposes, wire 0.085. Now the wire isn't actually that diameter, but where they grabbed it here to bend the eye and the fact that it may not be perfectly straight will all affect that. And I need to know how thick or how wide I need to make this in order for this to fit. And usually if it's less than, I don't know, 4 or 5 thousandths difference between the maximum dimension here and the maximum dimension here, I just run with this, because you're not going to get enough flashing down the hook shank to matter. Now you get down here, it's going to be even different, because they bend this and a lot of times flatten it, so it may actually be wider here and thinner here. But for a lot of, for say a jig head or a weighted hook where all the weight's up here, that doesn't really matter, okay? But I do need, okay, anyway, so first dimension I get is the maximum largest area that I need is the maximum thickest area of the wire. It's about 0.085, right? Wire 0.085. And then I need the overall length of the hook. And you might think, well, that's not important if you're only working up here. It is if I'm designing the whole mold, not if I'm just designing a jig head, maybe not, but I'm designing a mold. So I need to make sure it fits, or that I account for it hanging out however I need to. And I'm getting 0.245. So, or excuse me, 2.45. So 2.45. And then I need this width, and again you might go, well, if you're only working here, what do you need that? Well, if you want to cast more than one at a time, you need to know how wide the hook is so that you space them out appropriately. And I've got 1.065, roughly 0.65, 0.66. So Pencil that in. 1.066. And I need to know this. This is a hard one to measure. One of the things you want to try and do whenever you're taking a length measurement along the hook is to, at least, this can be difficult and I do it visually, but you want to make sure that the shank of the hook stays parallel to the beam of the caliper as well as you can. And I tend to hold it out and just so I don't really look at the measurement to start. I just look at keeping the beam looking like it's parallel, or the shank looking like it's parallel to the beam of the hook. Okay, and we're looking at 0.879. Might as well call it 0.80. 0.80. Now we have most of the measurements of the hook. Alright, but there's a couple more we need. We need the diameter of the eye. It's roughly 0.36. So we need to know how long the eye is until it goes completely straight, and this is kind of a guessing game here. It's another one of those things you have to do visually, or I have to do visually. If you have a better method, great. I would say 0.3. Notice I'm including this little bent part here before it gets straight up to about there. Okay, so I'm going about 0.345. Alright, and those are most of the measurements I would need to do, say, a simple thing like a cylinder weight along the shank of the hook from here to here. I would just make sure that this portion is all outside of the cavity, and that I pick a diameter that's large enough to, well, large enough to pour around a heavy shank of a hook like that, but also large enough diameter to hit my target weight without getting down here into the curve. And that's a very basic measurement there. That would be to make something like my cylinder jig. Let me be more specific. It would be something like to make a straight shank cylinder jig. And that's the basics of measuring it. I'm trying to think what else you might need to know. I might, if I was getting a little OCD and doing paper layout, redraw my rectangle on another piece of paper to actually be the physical size of the hook, and then trace the curve and so on, especially if I were sending it to somebody else. But that's the basics I need to create a rough 3D model of a hook. You know, and this point doesn't have to be accurate. I mean, we're not going to bury the point so that it interacts with a cavity or anything like that. We just need to know how far back it sticks up, so we don't design it in such a way that it hits something else. Just like we need to know how wide it is, so we can set more than one side by side. And if we're using different size hooks, we'd need measurements like this for all of them. But anyway, that's the most basic measurements I need for a cross-eye J hook. Now let's get a flat-eye jig hook out here and show you how I tackle that. Basically, to do the J hook, I have 1, 2, 3, 4 rectangles that I get rough measurements of, and I note what they are. And I might, just so that nobody gets confused, say if I was sending it to somebody else, just pencil in a rough something like that showing the hook. Okay, just so everybody knows what the measurements are. Now we're going to take a more conventional jig hook. I believe this is a 60-degree jig hook, and that's where a protractor comes in. This is a very fancy, very precise protractor, but but it's no different than any other protractor. Basically, all I'm doing here is making sure that this angle here is the same angle that the manufacturer says it is. And for the most part, they're pretty close, but I have gotten hooks that were quite a bit off there. This should be a 60-degree hook, so we're going to let's see here. Yeah, so we're going to go like this and lay the hook up here, and I lay this right on there and then turn it until those angles line up. I can't see any light. Snug that down and read it. And you probably can't read that, but it's very close to 60 degrees on that little vernier scale. And you can get more accurate than that, but I can't read this without a magnifying glass any more accurate than that. But it's a 60-degree hook. Okay, now for this one I'm going to have basically the same stuff, you know, a rectangle for the length and width of the hook. I'm going to have a rectangle showing the hook barb area, you know, that part. And I'm going to have two rectangles here because it makes more sense that way. Okay, this one shows the total height from the bottom of the hook to the top of the eye. That's going to go here. And then this one is going to be the diameter of the eye. Okay, that's going to go right here. And then this measurement here doesn't really have a direct representation on this sketch, you know, this eye length to where it goes straight. So I might make a note of it somewhere. But the first thing I'm going to do, just like I did on the J-hook, is I'm going to get a maximum wire thickness that I need. And it's usually here where you measure around the eye like this. That's usually the thickest thing that you're going to measure because they distort the end of the wire when they bend the eye of the hook. And it doesn't always line up. It's always good to check these measurements on 3 or 4 hooks also, and even out of multiple packages, and go with whatever is the maximum dimension. But here we're looking at about 0.083. So the first thing I'm going to write down is wire 0.083. Alright, and then the rest of the measurements, I can take them in any order at this point. Generally I like to get the length and the width first. And just like measuring the barb area, you have to have the shank as parallel as you can make it to the beam of the caliper. Right, and the length of this hook is 2.902. .902. And this isn't super critical that it's exactly to the thousandth, but you don't want it to be off by 10 or 20 thousandths. You know, just get it as good as you can. And then the same thing with this, I want to make sure that the shank of the hook is parallel to the jaw of the caliper as best I can when I measure this width. And again, it's not super critical, but get it as close as you can. Alright, and the width of the barb perpendicular to the shank of the hook is 1.025. So right here, 1.025, right? The eye of the hook is 0.248. If you don't have enough room to write, you can do something like that. 0.248. The height is 0.5017. 0.5017. 0.01, no, that's not right, 0.517. If something doesn't seem right, check it. You should know, measuring with a caliper, you should never ever get for practical purposes, you should never get 4 decimal places. Okay, 0.517. There's another note I might want to make, and that is that the is a 60-degree hook. And I measured it with a decent protractor. You don't necessarily have to have a fancy protractor like this one, but you do need to confirm that it looks that it is what it says it is. There's a couple other measurements you might want to get. That is the offset of the eye of the hook from the straight portion of the shank here. All right, and you could do that like this. Just draw a little rectangle with your, and just a rough sketch of the hook eye. Doesn't have to be fancy. Oh, in this case we're doing it like this. Okay. I'm kind of making this part up as I go along because I usually have some other tricks that I can do on the computer that you can't do with pencil and paper. Okay, let's do this again. Okay, here's the eye of the hook. More or less the way it is if you looked at it. Okay? And the shank's like this. We want this dimension right here from this edge to the shank of the hook perpendicular. Okay? And we want the same thing over here. Alright? You don't have to get those, but it will allow me to make a tighter fit for you. So anyway, 0.072, 0.072, offset to shank, and over here offset to, sorry about the shadows, I'm doing this in my office, I certainly don't want to do it outside. Alright, and this one might be a little harder depending on the rest of the geometry of the hook, but generally you want this to be perpendicular to this straight portion here. Okay? And I'm not sure I have that right, but I think I'm pretty close. Wow, that's a lot more offset. 0.172. Now, I'm not going to create something to this level of accuracy, but the better the level of accuracy you give me, the better I can create it. Alright? And you see what we're going with here? We're going with here. Allows me to get everything more or less in the right location, so that when I lay out the hook to make a jig head on here or to make a weight on here or what have you, that I can get it dialed in, and if we're making, say, a multi-cavity mold, they'll all fit. Because if we don't get those dimensions, you know, I might make the heads all perfect and they're like that. Well, obviously that's not going to fit. Okay? And now the thing I did with the eye of the hook is probably more important to do with the J hook. Let's get that sketch back over here, because this is going to be setting in the mold like this, and we may even have a tight tolerance between here and here for where we're going to put whatever's going on this. So let's just grab another page. It's best to do it all on one page for each hook, but we're going to do this on another page so we can make it a little bigger. Okay, we're going to do this part right here. Alright. And I'm drawing it bigger than the hook so we can see everything, right? We've got a hook that goes roughly like this. Okay. We want the dimensions we already took. That's the length until the hook straightens out, which was 0.345. This is, you can do this, say, if you make it large enough. 0.345. The diameter of the hook. Or diameter of the eye. I said hook, I meant eye. 0.36. Alright. And then we want the offset from the edge of the eye to the side of the hook shank here and here. And that'll help me know how deep I have to make that area where the eye rests when I carve the mold, when I machine the mold. Okay? And it's kind of a pain. You want to be perpendicular to the straight part of the shank of the hook when you take this measurement. And I'm going to make these sloppy, okay? But if you get flashing or other issues, the sloppier I make it, the more cleanup you're going to have. But I have to make it a little sloppy just to make sure it'll work. And that offset is 0.113. And the offset on the other side, I should be able to get a measurement of the diameter of this and the diameter of the eye and do the math, but I always like to physically check it also. Okay. Do this. There we go. All right, and that is 0.121. .121. Okay. Got that? Got that? Got the same basic thing here. Got the wire thickness. That one's all set. This one, that's that part. And that shows it like that. This shows the barb area of the hook. I've got the degrees and I've checked it. And I've got the maximum wire diameter and I've got it written down. And that's the information I start with when I start 3D modeling a hook. And a lot of times, because this part, when this part is not important for the model I'm making, I just wing it, or I take a picture of it and I trace it, or I just make something rough that looks close enough. It's just like the offset of this point. You know, usually I just make something rough that looks close enough, because this I have to account for, but this is the business end of the hook for what we're doing in the mold in most cases. Well, unless we're making a rear-weighted swim bait hook, then we would be concerned with this, but that's another project. I'm just showing you the basics of getting hook measurements today. And these are the tools you should have. Well, these are the tools you need, and a notebook, to do a straight shank cross eye hook, or flat eye, I guess that's called a flat eye hook, or to do a cross eye jig hook. Oh, you'd also need something to check the angle of the bend. That's it. I think that's all there is to it. Oh, let me zoom out. Can't zoom out anymore. There we go. Now we got everything in there. I hope that helps.